Hey ChemExcel. All right, this is dilution video 2. We're going to start off with calculations for the solutions from the first video and then wrap up with another example of how to do the calculations when you're solving for a totally different variable. Okay. All right, so these are the solutions from video 1. All right, in the image over here, you can see I've numbered them 1, 2, 3, and 4. All right, solutions 1 and 3 here, those were our stock solution. All right, not diluted at all. They were both 0.6 molar. You can see that they have the same color in the video. All right, and because they have the same color, that's just sort of more evidence that they have the same molarity. They were both at 0.6 molar. All right, solution 2 here started off looking just like number 1, but then we added water until the volume was 40 milliliters here. All right, and you can see that the number of dots did not change from solution 1 to solution 2. Right? It's got the exact same number of particles, but it's obviously a lower concentration. They're more spaced out at this time. Okay? We can also see it has the lightest color, right? And that's evidence that it has the lowest molarity of any of the solutions here as well, which makes sense because we did double the volume, right? Which was quite a big change. In solution 4, you can see it's a little bit lighter than solution 3. That makes sense, right? Solution 4 started off looking like solution 3. We added a little bit of water to it. So now the particles are a little bit more spaced out, right? That's going to dilute that color a little bit more as well, right? So based on looking at that diagram as well, the molarity is going to be between 0.3 and 0.6, right? We did not double its volume, right? They're not as spaced out as they are in solution 2 over here, right? But we also didn't leave it at that 0.6 molar. Okay, so see these calculations. This is the equation, the grandiose molarity equation. M1V1 equals M2V2. All right, M1V1 is all about the original solution. So the original concentrated solution. It's a weird U, sorry. And M2V2 is all about the final, all right, dilute solution. Concentrate and dilute are relative to one another, so it could start off fairly dilute in the first place, but make it even more dilute. So then it would start off concentrated, end up diluted, just relative to one another. All right, I've got a little diagram of how you might draw it on a homework problem or something. All right, we've got 20 milliliters of 0.6 molar. We add water. Now the volume is 40 milliliters. We want to know the molarity. So we reasoned this one out. So, well, if we doubled the volume, right, then they're twice as spread out, their concentration would be half as much. But if we plug everything in, we're saying that the original concentration was 0.6 molar, and that volume, undiluted, was 20 milliliters. All right, so 20 milliliters only goes with the 0.6 molar. It's the volume when it was 0.6 molar. But then after adding water, we don't know the concentration, right? That's what we're trying to solve for. But we do know that the new volume is 40 milliliters. So this is what your setup would look like. I don't have parentheses around M2. Right? I did write M2, okay? And again, like in the last unit, when I said order of your variables, for those of you who wanted to put your variables out of order, yes, it matters, okay? The left side of the arrow here is for everything you start with. The right side of the, or not arrow, equal sign, sorry. The right side of the equal sign here is for the solution that you're ending with or making. Okay. If we do the math on this one, we solve for M2, we'd have 0.6 times 20 divided by 40 is going to give us M2 equals 0.3 molar. All right, most common issue here is dividing by the wrong side. So I'm going to ask you to take a moment when I'm done with this sentence and pause the video and actually do the calculation for yourself and make sure you're getting 0.3, okay? A lot of people divide by the wrong side on these. Okay, so pause the video if you haven't done so, do the calculation, all right, and then you can move on. All right, here's the other two solutions. We had 40 milliliters of 0.6 molar, all right, and we added water to it. So just reading this question, we added water to the 40 milliliters of 0.6 molar copper chloride, which was actually, just blue water, all right, to a total volume of 50 milliliters. So again, it's just about picking out what did you start with, what did you end with, right? Here's our original solution. It's volume and concentration. Dump some water in there until the volume is 50 milliliters. We want to know that new concentration. You probably did some stuff with ratios, things like that. All right, I'm trying to figure out how to work this out. If what you did is correct, it does rearrange into this equation then. All right, so our original solution, we have 0.6 molar. All right, and the volume when it was 0.6 molar was 40 milliliters. We're looking for what concentration it is now after we've added that water. And the final volume, all right, is 50 milliliters. It is important to note that this over here is always the total volume, all right, that goes in here. If your problem is worded like you added 20 milliliters of water to 50 milliliters of this solution, your total volume would be 70 then. So just pay attention to the wording. That wouldn't be the technically correct way of doing the dilution, but you know, it is a way people do that. All right, so for this one, all right, if we solve for this, if we do 0.6 times 40 and divide that by 50, you should be getting 0.48 molar. So congratulations if that is what you had already figured out. If you go back and look at what you did to figure it out, all right, you should be able to see how you can rearrange it. All right, whatever ratios you set up, it'll rearrange to give you this equation too. They all mean the same thing. Okay. All right, one more problem. All right, just showing how this works out in a more realistic situation. I say this is more realistic because this is more like what really happens in a lab situation. All right, is that you know how much you need of something. All right, maybe you need 100 milliliters of 0.15 molar sodium sulfate here. All right, that's what you need. And you go in your storeroom and you see what you have. And the storeroom shows that you have access, in this case, to 1 molar sodium sulfate. Question is like, okay, what do? You're in the storeroom, you're staring at a bottle of 1 molar sodium sulfate. You know what you need, what do you do? Okay. So if we were to start with a little drawing on this one, all right, that's a weird test tube, we're just gonna go with it. We know that we're starting with 0.1 molar sodium sulfate, but we don't know how much of it we're gonna use. Right, like that initial volume, milliliters, we don't know. It doesn't tell us, okay? But we do know that if we add water to it, the concentration will go down. So we want the concentration to go down from 1 to 0.15. So we add water, and it's going to get to, obviously, a bigger volume. All right, we want that volume to be 100 milliliters, and we want that new concentration to be 0.15 molar. Okay. So filling things in, all right, we know M1, all right, is 1 molar. We do not know the volume we're going to start with. All right, if we go to the other side, we know we want to end with this dilute 0.15 molar, and we want that total volume of 100 milliliters. So if we do 0.15 times 100, and obviously just divide by 1 in this case, V1, I typed that in the calculator, which was ridiculous. Hopefully you see why that should have been done in my head. All right, V1 is going to be 15 milliliters. All right, now that doesn't fully answer the question though. The question does say, what do you do? And if you say V1 equals 15 milliliters as a response to what do you do, I'm going to come back with you just with, well, but what do you do? Okay, so in this case, we would want to measure 15 milliliters of, just check back, our original solution was 1 molar, it's in here too. Measure 15 milliliters of 1 molar sodium sulfate. All right, that's the sodium sulfite, let's fix that. Okay. All right, measure 15 milliliters of 1 molar sodium sulfate. So we've described our original test tube over here. You'd use a volumetric flask and some other specialized equipment for this if you were doing this in like an analytical chem situation, but that's not where we are. This isn't like a level 4 college course or anything. Okay, so we'll measure that out and then say, and add water to a total volume of 100 milliliters. That is what we would do. All right, if we do that, then we will have 100 milliliters of 0.15 molar sodium sulfate. Okay, all right, go do your practice problems. Bye.